Hello students, welcome back to Science Capsule, a perfect self-learning tool. We are learning the chapter carbon and its compounds, and so far we have completed 5 episodes, and all the episodes are equally important as far as the examination is concerned. If you have not watched those videos, since those are very important, I'll give the link in the I button and also give in the description. You can follow all those links and you can check out those videos. So this is our 6th episode. In this episode we will be learning the concept of a homologous series. Watch till the end of this video. I assure that you will learn, you will not forget the concept of a homologous series. So without wasting much time, let us start today's episode. Dear students, as far as homologous series is concerned, this is one of the most important topic because questions on this topic is very often asked in the CBSE examination. So due importance on this topic needs to be given. Let us understand this with some examples. We are very much familiar with the hydrocarbons. So hydrocarbons are those carbon compounds which is made up of only carbon and hydrogen. The lower member of a hydrocarbon is called methane. We are very much familiar. As the member goes on increasing, the number of carbon atom also increases. And we have also studied that the chemical properties of the hydrocarbon remains the same irrespective of the number of carbon atoms, whether they belong to lower member of hydrocarbon or they belong to higher member. Here I am taking an example of higher member of hydrocarbon, butane I am taking. So this we call it as butane, and this is methane with one carbon atom, and all other, the valency of carbon is to be fulfilled by hydrogen. And in the previous episode we have discussed about functional group, and the functional group can replace the hydrogen atom from the hydrocarbon. Here, regardless of the number of carbon atoms, their chemical properties remain same. Much variation in the chemical properties we won't see in the hydrocarbons, whether they belong to lower member, that is methane, or a higher member, butane, and other higher members of the hydrocarbon series. In the previous episode, we have seen various functional groups which can replace hydrogen from hydrocarbon, isn't it? Let us take some examples. Here it is the methane, and here I am drawing the structure of ethane. So this is the structure of ethane, isn't it? Now take another example of hydrocarbon with 3 carbon atoms. We call it as propane. This we call it as ethane. This we call it as propane. This is butane. If suppose a functional group called alcohol, this we call it as alcohol, replaces one of the hydrogen atom in each series of the hydrocarbon, then what will happen? Here in place of hydrogen we will have OH. Here the same functional group replaces a hydrogen from each series of the hydrocarbons or the higher members of hydrocarbon, then the structures will look like this. After replacing one hydrogen atom from each of the series of hydrocarbons, methane, ethane, propane, butane, the structure looks like this. Here we have got a series of hydrocarbons in which in each hydrocarbon a hydrogen atom is being replaced by same functional group. So the series of carbon compounds in which same functional group replaces hydrogen from the hydrocarbon is called homologous series. In the hydrocarbon series, the first member in the homologous series would be methane. Followed by methane comes ethane, propane and butane. Now in this structure, the molecular formula of this structure can be expressed as CH3OH, and its name would be methanol. So about IUPAC name or name of the carbon compounds we will see in the next episode. For now you just understand that this we call it as methanol because we have a functional group alcohol, so methanol. Here the molecular formula would be C2H5OH and the name would be ethanol. And here the molecular formula would be C3H7OH and name of the compound would be propanol after replacing one hydrogen by alcohol functional group. And here we will have C4H9OH and the molecular formula would be butanol. From the structures, it is very much clear that the next homologous series of methane is ethane, methanol is ethanol. The next homologous series of ethanol would be propanol, and the previous homologous series of ethanol would be methanol. Got it? Likewise, if you see the structure 3, then the next homologous series of propane is butane. The next homologous series of propanol would be butanol. Got it? Altogether, if you see the structures very carefully, then you will find that two consecutive homologous series will be differed by a unit of CH2. We can see this CH2. Now, let us understand this. See the structure of methanol and ethanol. If I remove one CH2 unit from ethanol, then you will find that the structure of methanol and the ethanol, after replacing CH2 unit, the structures are same. So we can say that two consecutive homologous series will be differed by a unit of CH2. Likewise, if you see the structure of ethanol and propanol, from the propanol, if I remove a unit of CH2, then you will find that the structure of ethanol and propanol, after removing CH2 unit, the structures remain same. So if you see all the structures, if you take two consecutive homologous series from any of these compounds, then you will find those structures are differed by CH2 unit. So on the basis of this, we can easily find out next and previous homologous series with the idea of a CH2 unit. If you want to find the next homologous series of any carbon compound, then you have to add a unit of CH2. If you want to find the previous or preceding homologous series of any carbon compound, then you have to subtract the molecular formula with CH2. So this is how we can find easily the next and previous homologous series of any carbon compounds. Let us understand by doing some of the exercises. As a practice, let me take the compound propane. Initially, the molecular formula we know that C3H8. To find the next homologous series, we have to add a unit of CH2. In order to find the previous homologous series, we have to subtract a unit of CH2. So here, by adding a unit of CH2, here we have 3 carbon plus 1 carbon will be C4. Here 8 plus 2 hydrogen will be 10. So C4H10. If you see the previous one, then we have to subtract 1 carbon from C3. So it will give you C2. And 2 hydrogen atoms need to be subtracted. So here we will get a C2H6. So the next homologous series of propane would be butane with the molecular formula C4H10. The previous homologous series of propane would be ethane with the molecular formula C2H6. Got it? Now likewise, let us see another example which contain a functional group. Let me take here chlorobutane. So the chlorobutane molecular formula would be C4H9Cl. To find the next homologous series, add one CH2 unit. So C4 in place of C4, C5, H9, 2 hydrogen needs to be added. So H11Cl. To find the previous homologous series, subtract a unit of CH2. So C4 minus 1 would be 3, that is C3, and 9 minus 2 would give you 7, and chlorine you have to write. So this is chlorobutane. This would be our chloropentane because it has got 5 carbon, and here this will be chloropropane since it has 3 carbon atoms. Very easy, right? So this is how you can easily find the next and the previous homologous series by adding and subtracting a unit of CH2 respectively on the molecular formula. So this is all about a homologous series. I hope you found this video useful. If so, hit the like button and share as much as possible to your friends. If not subscribe this channel and press bell icon so that you will receive notification on each of my upload. So that's all we have in today's video. See you all on next episode. Till then, take good care of yourself. Bye bye.